Hi everyone. Today we're going to study organizing data. That is, we will study frequency distribution. First, let us define some terms. The first term is ungrouped data. It means the data is raw. That is, it's not sorted into categories or groups. Second term is frequency. Frequency is the number of times a value of the data occurs. Next term is the relative frequency. It is the ratio, fraction or proportion of the number of times a value of the data occurs in the set of all outcomes to the total number of outcomes. The formula will be like this. Rf equals f over n times 100, where f is the frequency and this n is the total number of frequency. Next term is cumulative relative frequency. It is the accumulation of the previous relative frequencies. To find the cumulative relative frequencies, add all the previous relative frequencies to the relative frequency for the current row. And the last term is grouped data. In this case, the data is grouped into classes. There are steps in constructing frequency distribution. Step 1, we will make a table as shown. It means there will be 5 columns. For step 2, arrange data value in ascending order and place it in column A, that is for ungrouped data. Step 3, tally and count the data and place it in column B and C. Step 4, find the relative frequency of values in each class by the formula Rf equals f over n times 100. Step 5, add all the previous relative frequencies to the relative frequency for the current row. Let us see example 1. 20 students were asked how many hours they worked per day. Their responses in hours are as follows. These are the data. Construct frequency distribution. First, let's have our step 1, and that is to make a table with 5 columns. In step 2, we will arrange data value in ascending order. So we have data starting from 2, 3, 4, 5, 6, and 7. For step 3, we will tally each raw data in the data set and put in the corresponding data value in our tally column. So in here, it means 3 times the number 2 appears in our data set. The same is true with number 3. 5 times it appears. For number 4, 3 times, and so on and so forth. For the frequency column, we will simply count the tally. So it means to say, for number 2, 3 times it appears, so we will write here 3. So for number 3, it is 5, so we write here 5. For number 4, there are 3 tallies, so we write here 3, and so on and so forth. And then we will take the total, and this is now equal to 20. This 20 must be the same with how it is described in our problem. So it's written here 20 also. Now, for step 4, find the relative frequency of values in each class. Let's begin with our first row. Using our formula, we have this frequency 3. We will write here over 20, that is the total frequency, times 100. And the answer is 15. And this 15 we will copy in here. Using the same formula, we will fill all the blanks here, and here we go. We have now the relative frequency percentage for each rows. And the total of the relative frequency percentage must be 100. Now, for step 5, add all the previous relative frequencies to the relative frequency for the current row. Okay, let us begin with the first row. This number 15 we will copy here, and for the next value we will add this 15 with this 25. So 15 plus 25 will be 40. Then 40 plus 15 will be 55. 55 plus 30 is 85. 85 plus 10 is 95. And 95 plus 5 is 100. The last entry of the cumulative relative frequency column is 100, indicating that 100% of the data has been accumulated. So, we are done with our example 1. This is now our answer. Remember, because of rounding, the relative frequency column may not always sum up to 100. And the last entry in the cumulative relative frequency column may not be 100. However, they each should be close to 100. Let us have example 2. This time for grouped data. The table represents the heights in inches of a sample of 100 males semi-professional soccer players. Find relative frequency and cumulative relative frequency for the frequency distribution. This is now the given table. Now, let us write our step 1. For our table here, we are going to write 4 columns. In our first column, the heights are there, and we can see the classes. The frequency is here on the second column, and it is already given. So we don't need the tally column now. Next, we are going to find the total of the frequency, and this is equal to 100. This is based on how it is described in the problem that there must be 100 male players. Next is the relative frequency. This time, we are going to use this formula to express and show that relative frequency can be decimals also. Let's begin with our first blank. So Rf equals the f, and that is the 5, over the n, which is 100, and the quotient is 0.05. We will copy this value in the first row. Next, we're going to fill in the full columns. Using our formula, we will have 0.03 in the second row, 0.15 on the third, 0.40 in the fourth, so on and so forth. If we get the total of this, we will get a whole number 1. Next, we will now fill in the cumulative relative frequency. For our first row, we will simply copy this 0.05. For the second row, we will add the 0.05 to the 0.03. So we have 0.08. And that pattern we will follow. 0.08 is added to 0.15, and that is 0.23. The 0.23 plus 0.40 will get 0.63. 0.63 plus 0.17, we will have this 0.80. 0.80 plus 0.12, we will get 0.92. The 0.92 plus 0.07 will have the 0.99. 0.99 plus 0.01 equals 1. So this is now the final answer. Remember, because of rounding, the relative frequency column may not always sum up to 1. And the last entry in the cumulative relative frequency column may not be 1. However, they each should be close to 1. Today we're going to study frequency distribution. In statistics, we use various tables and diagrams to represent data, which will facilitate easy interpretation and analysis of data. Frequency distribution is a representation of data in tabular form, showing classes or categories with corresponding frequencies. We are going to study two types of frequency distribution. In this video, we will discuss the first, grouped frequency distribution. The second is categorical frequency distribution, and we will discuss this in the next video. For the grouped frequency distribution, and this is the main focus of our video today, there are steps to follow in constructing a grouped frequency distribution. The step 1 is to form the classes or class intervals. There are 4 sub-steps for this step 1. The first, or letter A, pick out the highest and the lowest values and find the range of the data. The formula for the range equals highest value minus lowest value. Letter B, determine the class intervals. Normally, the class intervals will be given in the problem. But if you are a researcher, you will be the one to decide on the number of class intervals. It says here, number of intervals should be between 5 and 12, and they usually have equal widths. Letter C, find the class width, denoted by I, by dividing the range by the desired number of class intervals and round up the quotient. Step D. Write the first class interval using the lowest value as the lower limit, and the upper limit is the value of lower limit plus class width minus 1. Write the next class intervals accordingly. Step 2. Tally the values in the data set into the classes formed. Step 3. Find the frequency of each class by totaling the tallies. Step 4. Construct a column of relative frequency distribution using the formula RF, that stands for relative frequency, equals F over N times 100. Let us see an example. The average quantitative GRE scores for the top 30 graduate schools of engineering are listed. Construct a grouped frequency distribution with 5 classes. We have here 30 raw data representing the GRE scores of 30 graduate schools of engineering. And let us now construct a group frequency distribution. The step 1 is to form the classes or the class intervals. Let's start with step 1A, and this is to find the range. First, let us identify the highest value and the lowest value. Browsing through the data, we can see that the highest value is this 780 and the lowest value is 746. So the range is, to get the difference, R equals 780 minus 746, and this is equal to 34. Step 1B, we will determine the number of classes, and it is given already in our problem. So there will be 5 classes. Step 1C, to compute for the class width, symbolized by letter I, and this is equal to the range divided by the number of classes. So we have 34, that is the range, divided by 5, the number of classes. This is equal to 6.8. So this quotient we need to round up, and this is now round up to 7. Take note that this is rounding up and not rounding off. For further examples, we may say that this 6.1 is round up to 7. Also the 6.3 is round up to 7. Along with 6.5 and 6.9 are all rounded up to 7. The 6.0 is rounded up into 6 itself. So it means to say, we can conclude that any decimal added to the number 6, it will be rounded up to the next whole number, which is 7. Let's go now to step 1D. Write the first class interval using the lowest value as the lower limit. We can use a value a little lower than the lowest value, depending on the purpose of the author. And I will continue. And the upper limit is the value of lower limit plus class width minus 1. Write the next class intervals accordingly. At first, we need to show a column for class intervals. For our first class interval, we will write the lower limit. In this example, we will use the lowest value, the 746. That is our lower limit of the first class interval. And then, for the upper limit, the lower limit itself plus the class width, which is 7. But we must have to subtract 1. And when we simplify this, this is equal to 752. And we will put this value in here. It means to say, the first class interval is starting from 746 up to 752. So when we count, there are 1, 2, 3, 4, 5, 6, 7 numbers for the class interval. And the 7 numbers is the one being described by our class width, which is 7. And then we will continue to write the next classes. For the second class, we ended our first class interval into 752. So the next class must start with 753. And this 753 is the lower limit of the second class interval, and the upper limit is 759. We follow the same pattern based on our first class interval. And that idea will be implemented on the other class intervals. So in here, we are able to write all the class intervals. So let us check. There are 1, 2, 3, 4, 5 class intervals as required by our problem. Also, let us check with our lowest value, the 746, that it belongs to the first class interval. Also, the highest value, the 780, belongs to the last class interval. So we are checking here that all the numbers or raw data will find a specific class interval. Next is, we will go now to step 2. And this is to tally the values in the data set into the classes form. We need a column for tally. So what we're going to do is to go through each of the data. We will tally them according to their respective classes. Let's begin with the first number, the 767. And this number belongs to this group. We will strike that number and put a tally corresponding to that datum. Next, the 770 also belongs to this group. So we will go through each of the data. So this is now our complete tally list. For the step 3, let us find the frequency of each class by totaling the tallies. So we need another column for the frequency. We will simply count the tally for each class intervals. So it means for the first class interval, we can see here that there are 4 tallies. So we will write here 4 in the frequency. For the second class interval, there are 6 tallies. For the third class intervals, there are 8 and 9 and 3 for the fourth and fifth class intervals respectively. Next is, we will take the total of the frequency, and this must be equal to 30. It means we did not miss anything in our raw data. For step 4, let us construct a column of relative frequency distribution using the formula Rf equals F over N times 100. So we need a column for the relative frequency, and our formula is here. For the first blank here, it means we're going to use the frequency of this first class interval, which is 4, divided by the total number of frequency, which is n, the 30. So you see here we have 4 over 30 times 100. And the answer is 13.33. This value we will put on this blank. And there we go. So let us complete the remaining blanks using our formula here. So this number 20 comes when we have the number 6 divided by 30 times 100. This 26.67 comes when we have 8 over 30 times 100. This number 30 comes when we have 9 divided by 30 times 100. This number 10 comes when we have 3 over 30 times 100. So we are now complete with the values for the relative frequency. And at the bottom, we're going to take the summation. And the value must be equal to 100. This is our final answer. Today we're going to study categorical frequency distribution. Categorical frequency distribution is a representation of data in tabular form showing categories with corresponding frequencies. Here are the steps on how to construct categorical frequency distribution. Step 1. List all categories in a column. Step 2. Tally raw data to corresponding categories. Step 3. Write the frequency for respective category with respect to tallies. Let us see one example here. 35 Army cadets were given a blood test to determine their blood type. The data set is given here. Construct a frequency distribution for the data. Complete the table below. In our table, we have 4 columns. The first column is for the category, which is the blood type. We can see here there are 4 blood types. We have A, O, B, AB, respectively. The next column is for tally, followed by another column for frequency. There is a column also for relative frequency. Now, let us begin with our tallying of the raw data. Let's begin with our first datum, that is A. We're going to tally this value in the column tally opposite category A. So we have here the tally, and we will strike out that first datum to be sure that we will not repeat that same datum again. This striking out of datum we will do on every raw data here. And to summarize, we have now the complete list of tally of our data set. And then let us go to the next column. This is for the frequency. We will simply count the tallies for each blood type. So for our first blank, this is for the blood type A. So we have 8. For the next, we have 14, and this is for the blood type O. The next frequency is 8 for blood type B, and the next is 5 for blood type AB. And then let us compute for the summation. We will take the sum of all the frequencies, and this is equal to 35. This number must be equal to the number of data in our data set. The next is, let us fill in the relative frequency column. The formula is given here. RF, that stands for relative frequency, equals F, that is the frequency, over N, that is the total of the frequencies, times 100. So for the first blank, we're going to have this number 8 divided by 35 times 100. And this is equal to 22.9. This value we will copy on the first blank. So there we go. And then we will use this same formula to compute for our remaining relative frequency. So we have this number 40. It comes from 14 divided by 35 times 100. This 22.9 here is the same with our relative frequency of the blood type A because they have the same frequency. So we use the same computation. Now, the 14.2 comes when we have this 5 divided by 35 times 100. And then let us take the summation of the relative frequency, and this must be equal to 100. By the way, the relative frequency of each category describes the frequency of the category in relation to the total frequency. And this is our final answer. I hope you learned something from this video. See you again next time.